What's up everyone, welcome back to my channel. Today we're going to look at an algebra problem which is finding the sum of the first n natural number terms at 1 plus 2 plus 3 all the way up to n. And of course we can use the sigma notation to actually shorten our entire sum. And perhaps most of you have already known that this has a closed form of 1/2 n times n plus 1. But today we're going to ignore the fact that we already know it and see how we can actually approach this problem so that we'll actually get the closed form. In other words, we're not trying to prove that that closed form is true, but we're trying to pretend that we don't know the closed form and we want to find out that closed form. So we're going to use two different methods to actually approach this problem. Here comes the first method. This first method was actually found by the mathematician Gauss, Gauss, who actually tried to add up the first 100 terms when he was 9-year-old. And in general, we still can use the same method. We just need to change the last term 100 into any variable n here. How do we do it? First, we're going to set this sum here as some variable capital S, such that we have 1 plus 2, S equals 1 plus 2 plus 3 plus dot 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 to the last term n. Then, since we are adding finitely many terms, we know that no matter how we rearrange the order of this finite sum, we'll be able to get the same results back. In other words, we'll actually get the same value regardless of the order of this series, finite series. So in math, we call this absolute convergence. Then we can actually change our order in the following way. We're going to flip the order of this right-hand side such that we get n plus n minus 1 plus n minus 2 plus all the way down to 1. In other words, we're going to rewrite in a decreasing order instead of an increasing order. But we still can see that there are exactly n terms, and those n terms are exactly the same except in a different order. So that now we can just add the two equations together. Yes, we're going to pretend them as equations, such that on the left-hand side, we know that those two should end up with the same value, which is what we call S at the moment. So we have S plus S to give us 2S. And then on the right-hand side, as we try to line up all the terms in the following way, the first term will become 1 plus n, which is n plus 1. And then for the second term, we have 2 plus n minus 1, which is again n plus 1. Third term will also be n plus 1 as we add them together. And in fact, if we add all of them together, we will always get n plus 1. Now, how many n plus 1 do we have? Let's see. For the first equation, we know that there are n terms in total. And of course, in the second equation, we also have n terms. And since we pair up each term together, so we will always end up with n terms here. In other words, we now have n copies of n plus 1 adding together, so we just have n times n plus 1 on the right-hand side of the equation. And therefore, as we divide 2 on both sides, we'll actually get that this finite sum of the first n natural numbers is in fact equal to 1/2 times n plus 1. Alright, so that was the first method. Now we're going to move on to the second method, which I personally call it an algebraic method. And here is what we need to know. So consider the following. If we have an expression, x plus 1, quantity squared minus x squared, of course we can use difference of squares to factor them out, but we can also try to break it in the following. As we know that this is a square of sum, we can rewrite as x squared plus 2x plus 1 And then we have minus x squared. And now as we subtract the x squared, we actually get 2x plus 1. Why is this important in our expression? Here is the reason. Now we're going to replace all the x by the natural numbers that we actually have in the expression, such that the first equation that we get will be 1 plus 1, which is 2 squared minus 1 squared. As we say that we start with x plus 1 squared minus x squared. Then using the expression, we'll end up with 2 times x, which is in this case 1, plus this constant 1. Now notice that this one and this one are actually different. The first one that's attached with the 2 is based on the variable that we set up, where this one here is just a constant no matter what variable we choose. So if we move on to the second equation, which is 3 squared minus 2 squared, we'll actually get 2 times the variable 2 that we choose plus 1. And then if we choose x equals 3, we will get 4 squared minus 3 squared equals 2 times 3 plus 1. So on and so forth until we actually get to the term n plus 1 squared minus n squared, which is equal to, again, 2 times n plus 1. Now, as we list out all the equations here where there are n equations from 1 to n for our variables, we are going to add them all up, just like what we did in the first method. Now, if we add them all up, on the right-hand side, we have 2 times the variables, which is actually from 1 to n. In other words, it is exactly what we are trying to find, and we can just write it in the short form, 2 times the sum of k, where k starts from 1 all the way up to n. Then we also have plus n copies of 1s. Again, there are n equations in total. So in other words, we'll just have plus n here. Now on the left hand side, if we compare between the first two equations and as we add them together, we see that the 2 squares will actually get cancelled out. Now, between the second and the third equation, we have the 3 squared cancelled out. So on and so forth until the last equation, we will actually get rid of the n squared. So that as we add all of them up, the left hand side will just turn into n plus 1 squared, which is the last term that we have, minus 1 squared, which is from the first equation. And therefore, now as we move to the right hand side of the board, we will actually get n plus 1 quantity squared minus 1 squared, which is actually equal to minus 1. That's equal to 2 times the summation k equals 1 to n plus n here. And since we're trying to find out the closed form of the summation here, we actually get 2 times the summation is equal to everything on the left hand side is now moved to the right hand side, or copied to the right hand side. And then for the plus n on the original right hand side, we'll subtract it to the left hand side and put it back to get minus n. And we now can just try to factor out the negative between 1 and n such that we have minus the quantity n plus 1. And we can just do the algebra by factoring out the n plus 1 to give us n plus 1 minus 1. And of course, as we reduce between the ones, we'll just have n. And therefore, as we divide 2 on both sides, we have the sum of the first n natural numbers is actually equal to 1/2 times n plus 1, as we expect. That's it. It's not too difficult, right? I hope you all enjoyed this video. And don't forget to like and subscribe my channel so that you'll be able to find more of my other videos. And you can also turn on the notification such that you don't miss any of my new videos when they come out. If you have any thoughts, you can leave your comment down below. I'll see you guys next time.